So the first one is 6-4, which is properties of rectangles. Okay. First, I got your riddle for today. If an electric train's traveling south, which way is the smoke traveling? Any takers? Excellent. Electric, no smoke. Good. All right. So we have properties of rectangles and determine whether parallelograms are rectangles or not. Again, most of these theorems are on your postulate sheet. Okay. So we're going to be looking at different properties of rectangles and parallelograms. This is on your postulate sheet. So just make sure you have it because you'll want to look through it. But it says if a parallelogram is a rectangle, then the diagonals are congruent. Then it's the same. So if I tell you something's a rectangle, you know from A to C is congruent from B to D. Okay, diagonals are the same. Whereas in a parallelogram, what do diagonals do? In a general parallelogram, what do they do? They're not always the same. They, remember that? They bisect each other, right? Which is also true here. But the diagonals themselves happen to be the same in a rectangle. And here's the other theorems that are on your postulate sheet. Okay, opposite sides are congruent and parallel. We know that already from knowing what a rectangle is. Opposite angles are congruent. Consecutive angles are supplementary. Those are the same things as a parallelogram. Diagonals are congruent and bisect each other, and all four are right angles. Right? We know these things from looking at a rectangle. Okay, so if you know a shape is a rectangle, you know a lot of different things. The difference between it and a generic parallelogram is diagonals are congruent to each other. Otherwise, all the other theorems stay the same. All right, so here, if I have this quadrilateral RSTU, okay, and I give you RT is 6x plus 4, and SU is 7x minus 4. Find what x is. So I gave you that diagonal and that diagonal. Based on the previous theorem, what do we know about diagonals of a rectangle? That they are equal. Right. So we know that 6x plus 4 must equal 7x minus 4. Okay. Subtract 6x from both sides, add 4 to both sides, and I would get x is 8. Right. Subtract 6x, 1x, add 4 to both sides, get 8. I don't ask you, but then if I ask you what are the diagonal lengths, you can take that 8, plug it in here, 48 plus 4, 52. In here, 56 minus 4, 52. So in this case, both of these diagonals would be 52 units long. Okay? So nothing too crazy there. Diagonals of a rectangle are congruent. Also bisect each other. But they're congruent. So in this case, from U to here would be 26. Same thing here. We don't need to write this one down and go through it, but I give you two diagonals. Okay. FH and GE. Applying those properties, those two must be equal to each other. Okay. On the quiz, when we were talking about parallelograms, I had some people just automatically set everything equal to each other. Remember, that's not always true. Be sure to label what it gives you. In this case, they are equal to each other. When you solve that for x, you'd get -5. Okay. Angles of a rectangle. So if I gave you these rectangles, I'll give you a second to draw that if you'd like. It says this is a rectangle, which is also a parallelogram, but it's a rectangle. Find x. Okay. I'm given this angle, and that one. I know since a rectangle is a parallelogram, that alternate interior angles are congruent. For example, this would be like one on the homework you just looked at. There's my two transversals, or my two lines, parallel lines cut by a transversal. I know that this angle and this angle would be the same in a parallelogram because they're alternate interior angles, right? But this one has a y in it, this one has an x in it. You run into that problem on your homework, except you have two equations, so you can use one to solve another. We'll come to that here a little bit later, though. So I could set those two things equal, but then I don't have any way to solve that. I don't have another equation I can use. So I need to look at these two angles. Now, what do I know about those two angles? Right. I'm not 100% sure if they're equal, but I know they make a right angle. Okay? I know that in a rectangle there are 4 right angles, so I know those two must be 90 degrees. So in this case, I don't set them equal to each other. They are going to add to equal 90, right? 5x plus 8 plus 3x plus 2 has to equal 90. Combine my like terms. Subtract 10 from both sides. Divide both sides by 8. So x would be 10 in this case. Then if I wanted to find out what each angle was, it didn't ask me to, but if I wanted to, okay, I could plug in 10, 50 plus 8, this one is 58, 30 plus 2, this one is 32. Which means this one would have to be 32 also. So if I wanted to find y, since I know that angle is 32, I know that one must be 32, so I would take 6y plus 2 equals 32 and solve it. Didn't ask me for it, but I could find that. And y would be 5. In this case, instead of giving me two angles that add to equal 90, I have an alternate interior pair of angles here. One here, both with a variable just x, so those I would set equal to each other. Right? So make sure it's not always just set them equal to each other. It's not always add to 90. Sometimes they might add to 180 if they're supplementary. Consecutive angles are supplementary, remember? Okay. So make sure you label what's given to you. We may want to talk about this one, though, because this may come up since this has a x squared variable. Again, those are alternate interior angles. So those are equal to each other. Yeah. So we would need to solve this for x, okay, which, since it's a quadratic, I have something to the squared, x squared, and then also a variable of the first power. Means I need to get all of this on the one side of the equal sign. Okay. So I can move, let's say I move this over by adding it. That leaves me with x squared plus 49 equals 14x. And then let's move that 14x over because I'm trying to get everything on this side. This is just a review of factoring or solving quadratics here. But I have x squared here. Let's say I move the minus 14x next. Plus 49 equals 0. So I need to solve this equation. Okay, everybody see what I did? I just moved everything over to the left side. Okay, let me erase the rest of this work here. So let's just review how to solve these when you have a quadratic. X squared minus 14x. Plus what? When I added 47 to 2, I got 49. I moved everything to the left there. So I need to solve this. One way you can do it is by that quadratic formula, negative b plus or minus square root b squared, that formula, right? Let's say we're going to factor it. Remember, to factor it, I need two numbers that multiply to give me the constant, add to give me the coefficient of x. And a lot of times we organize that information by putting it in this x. What are two numbers that multiply to give you positive 49, add to give you negative 14? Both negative 7s, right? Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 is negative 14. So these are the two numbers I write my two binomials with. X minus 7 and x minus 7. Yes, at the very end, right. So I broke this down into two binomials because if you were to FOIL this out, remember to multiply the first outside, inside, last, you would get this back. So all I did was I broke this down into two binomials. The reason I did that now is because I know if this set of parentheses was equal 0, the whole thing would equal 0, or if that set of parentheses would equal 0. Which it happens to be the same thing. What does x have to be for either one of those set of parentheses to equal 0? Have to be 7, right? If x was 7, that'll be 0 times 0, which is 0, which is true. So x would be 7 in this case. So remember, when you have a quadratic, something that's squared, and then another variable of the first power, get them all on one side of the equal sign, set it equal to 0, and then you can factor it. Two numbers that multiply to give you the constant, add to give you the coefficient of x, write your two binomials, solve for when each one of them is equal to 0. If it's the converse of a previous one. If the diagonals are congruent, then you know it's a rectangle. So if I gave you a figure and said AC is congruent to BD, you know automatically this is a rectangle. Then you can say angle, all four of those angles are right angles and so forth. Okay. So if I gave you this information, okay, this guy is building a swimming pool, okay, he measures the length and width so that opposite sides are parallel. He also made sure that measure the diagonals. That the diagonals are congruent. How does he know each angle is 90 degrees? Okay. So you know each side is parallel, you know the diagonals are congruent. So the test you would use is since the diagonals are congruent, it must be a rectangle. Okay. It's applying that last theorem. If the diagonals are congruent, then it's a rectangle. Also the converse of that is a theorem. If it's a rectangle, then the diagonals are congruent. Okay. Last one I want to go over here with rectangles. Okay. So you may want to write down these vertices. You don't have to graph it, but you may want to write down each of these vertices. If I give you 4 vertices, okay, and tell you they make a quadrilateral, and I went ahead and graphed them there, okay, determine whether that is a rectangle, okay, using the slope formula. Because remember, one of our theorems says if it has 4 right angles, then it's a rectangle. So I need to know how can I test that these 4 things are rectangles. Okay. And it says using the slope formula. Well, what's the relationship between 2 line segments and slope? Remember, parallel lines have the same slope. What do perpendicular lines have? Remember that? Opposite reciprocals, right? So if we can find the slope between each pair of these sides, and they are all opposite reciprocals, then it's going to be a rectangle. Okay. So, first, let's find out the slope of AB. Take the second y coordinate minus the first, second x coordinate minus the first. So the slope of AB is negative 2/3. Let's find the slope of BC. Remember here I'm using y2 minus y1 divided by x2 minus x1. The slope of BC is negative 3. Okay. So is this a right angle right here then? Is that a right angle? Based on knowing these slopes, is that a right angle? Are these opposite reciprocal slopes? Wait, I think this should be a positive. Oh, that's my equal sign. I treated that as a negative. Right? No, that's right. Let me fix this. That was equal. Then it's 3 minus 1, which is 2. Sorry. That's 1/3. There we go. Sorry, I treated that negative as an equal sign. So, is this a right angle now? Sorry. Yes, it is, because these are opposite reciprocals, right? So that's a right angle. I know that. Let's find the slope of DC.
Wait, what slope is this? When you just write the red?
The red one is this one, between those 2 coordinates.
Oh, is that A and B?
That was AB, yeah. Okay. So then if I take y2 minus y1 over x2 minus x1, is that a right angle? Yes, because the relationship between those 2 slopes are opposite reciprocals. Okay? So now I know that's a right angle. And then finally, let's say I looked at AD. y2 minus y1, x2 minus x1. So, this, opposite reciprocals, where those lines meet, is a right angle. And then finally, if I look at the red and the orange one, here and here, opposite reciprocals, that's a right angle, so that is a rectangle. See how we did that? In this case, if we are going to use the distance formula, we won't go through this one. We can find the distance of all those sides and see if opposite sides were congruent. Okay, to see if it forms a parallelogram in a rectangle. In this case, it would.